when I said proofs were going to get better and we'd start understanding them a little more? Well, I think that's about to happen here as we start to prove triangles congruent. Okay, when we prove that triangles are congruent, there's 4 things that we can use to prove triangles congruent. Today we're just going to focus on 2 of them. We're going to focus on our SSS and SAS. Well, the first one, the SSS, stands for side, side, side congruence. And that means if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles have to be congruent. So for example here, I have BC congruent to FE, and technically BC congruent to EF, right? So I gotta have the B and the E match up. And then I have AB congruent to DE and AC congruent to DF. So because I have all 3 sides being congruent to the other 3 sides, I could say that the triangles are congruent. So I could say triangle ABC is congruent to, I gotta be specific on this, so A matches up with D, I believe, right? So I have to say D, and then B matches up with E, so D, E, F, because F and C correspond as well. So you have to be specific when you name your triangle congruences, because the vertices have to correspond. So side, 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 that's our first one. So let's use it in a proof here. So basically, if I'm going to use side, 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 I have to have 3 side congruent statements. Right now, I'm given 2 congruent statements. So let me write these first in my given. So QU is congruent to AD, and QD is congruent to AU. That's given, and I'm going to draw that in my picture. So I got QU right there, congruent to AD, and QD congruent to AU. Well, if I want to get the 2 triangles, QUD, so here's one triangle, congruent to the other triangle, ADU, the only thing I know how to do that is to get all 3 sides congruent to all 3 sides on the other triangle. So far I got 2 of them, don't I? So how do I get the 3rd side into play? Don't they share that side? They share this side, this DU. So what would I have to do? It has to be congruent from one triangle to the other for that side. So DU, I have to state, is congruent to itself, because I have to have 3 side congruent statements in order to have side, side, side. And having something congruent to itself, we learned that the other day, that's our reflexive property. Reflexive. So now if I look, I got one side congruent to another, the second side congruent to the other, and the 3rd side. So I have all 3 side congruences, so I could state that these triangles are congruent, just like it did up here. So QUD is congruent to triangle ADU, and that is our side, side, side congruence. So we put side, side, side. So there's our first way to prove that triangles are congruent. If all 3 sides are congruent, then the entire triangles are congruent. And looking back, if all 3 sides are congruent, that means all 3 angles would be congruent to the other angles as well, right? Because if triangles are congruent, then all sides and all angles are congruent. Okay, so I know that. But I didn't have to prove anything about their angles, because as long as all 3 sides are congruent, then the triangles are congruent. And I could use that in other situations besides proofs. So it gives me 2 triangles, triangles DVW and triangle LPM, gives me their vertices, and asks me, are they congruent? Well, one way I can figure out if they're congruent is if the side, 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 if I have 3 sides congruent to another 3 sides. So what do you think I would have to do there? Yeah, I'm going to have to actually find the distance of each side. So I'm going to have to find, looking at my first triangle, find the distance of DV, find the distance of VW, and find the distance of DW. And then I'll have to do the same thing for the other triangle. Find the distance of LP, find the distance of PM, and find the distance of LN. And how do we do that? You guessed it, distance formula. So the square root, looking at dv, the distance between my y's is 1, So I'm going to take 1 squared. The distance between my x's is 4, so 4 squared. So I get the square root of 1 plus 16, which is 17. Skipping some steps here. Let's see if it's the same as LP. So the square root, the distance between my y's is 4, so 4 squared. The distance between my x's is 1 squared. Like the square root of 16 plus 1, which is 17. So far, so good. These two guys are congruent, right? Square root of 17, square root of 17. And I just keep going through. So now I check between VW. So the square root of, well, the distance between my y's is 2, so 2 squared. Distance between my x's is 6, so 6 squared. I'm just subtracting them. We've been doing this for a while, so I'm kind of rushing through that. So 4 plus 36 gives me the square root of 40. And I don't need to simplify anything because I'm just looking to see if this becomes the square root of 40 as well. So distance formula, distance between my y's is 6, so 6 squared. Distance between my x's is 2 squared. And if I look, these are the same thing right here. So I'm probably good with that. I don't actually even need to simplify to here. I know it's going to be the same. Okay, so good. And lastly, I'm looking at DW. So distance between my y's is 3. So the square root of 3 squared plus the distance between my x's is 2 squared. So I got 9 plus 4, which is the square root of 13. Let's see if that matches up. Distance between my y's is 2. So 2 squared. Distance between my x's is 3, so 3 squared. Get the exact same thing, don't I? So are these triangles congruent? Yes, they are. And why are they congruent? Because of side, side, side. Okay, it's the same thing except I actually proved them by the distance. My other one is side, angle, side. Now it has to be in that order. I have to have side congruent to another side, and then right after that have an angle congruent to another angle, and then right after that have a side congruent to another side. So if I look down here, I have BC congruent to FE, or EF. And then right next to it I have angles congruent, right? Angle B congruent to angle E. And then right after that, AB is congruent to DE. So it goes one, then the other, then the other. So it has to go in order. So BC was congruent to EF, and then I had the angles, and then I had the other side. So it has to go in order to use that congruence. So AB congruent to DE. Side, angle, and then the side. Let's try to prove some more triangles congruent. So I can either use side, 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 or side, angle, side now to say that triangles are congruent. Well, I know that G is the midpoint of EI and FH. And what did we talk about before? Always start with your given. Use the given. Well, what do I know about midpoints? Well, if G is the midpoint, wouldn't I know that these would be congruent and these would be congruent? So let it state that. I have to state it. You can't just visualize and say, like, yeah, they are, because state it. So I'm going to say FG is congruent to HG. And I'm also going to say that EG is congruent to IG. And we just said that's because G is the midpoint, so it's the definition of a midpoint. I could also say the midpoint theorem, because there's a theorem for that. Either way is fine. Well, could I get FE and HI congruent? I don't think I can. There's nothing else given that's going to help me get those congruents. I can't do side, side, side. Well, my only other option is side, angle, side. Well, if I look at my left triangle here, I got a side. Could I get this angle to go with the side, angle, side here? Could I get this angle and this angle congruent? Because that'll let me do side, angle, side. Sure I can, because what type of angles are these? They would be vertical, aren't they? So I could say angle, I can't just say angle G, because I don't know which angle I'm talking about. I'd have to say angle FGE, or EGF, is congruent to, it's vertical, so angle IGH. And we just said, I could say definition of a vertical angle, or it's actually a theorem as well. Vertical angles theorem. Either way is perfectly fine. And so now I have the side, angle, side, so I can state my triangle congruence. So triangle FEG is congruent to triangle HIG side, angle, side. Okay, side, angle, side. So far I can only use side, 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 or side, angle, side to prove triangles congruent. Last one. So in this case, I'm trying to get angles congruent. In the end, I want to say angle Q is congruent to angle S. Well, if I take a look, we're in triangle congruences right now. Somehow, if I could say that this triangle, RQT, is congruent to this triangle, RST, that would automatically make Q and S congruent, right? Because all angles and all sides are congruent in congruent triangles. So let's go through this. So I want to get to those triangles being congruent first. So let me get my given now. RQ parallel to TS. Probably going to use that. Just put my little lines there. Given. And then I got RQ is congruent to TS. Let me go ahead and mark that on my picture here. RQ congruent to TS. So I got sides. So am I thinking side, 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 or side, angle, side? Well, I have this parallel, right? I got the parallels. So I'm probably going to bring in one of my four things, right? Alternate interior, alternate exterior, corresponding, or consecutive interior. Let's take a look. Well, if I extend my parallels and look at a transversal, probably going to use this one that's cutting through it here so I can break up my angles of each triangle. Well, if we notice, I have alternate interior angles, don't I? So those two would be congruent. And these two would be congruent. But I'd have to state that. I could state them all, or I could figure out which ones I need. Well, I'm probably going to use side, angle, side for triangle congruence now. So I have a side, and then an angle for this triangle, and then I'm going to try to get this side in the middle here. Well, that means I want to use this angle, so I don't need to worry about those green ones. So I have to state the red ones here. So I got to say angle QRT. See how I named that one? QRT. QRT to get this angle. And that's going to be congruent to, I can go STR. Angle STR. And we said those are alternate interior angles because of the parallels. Alternate interior angles. It's really a theorem. I'm okay with just alternate interior angles. So now I got a side, and then the angles, and now I can get the side after that. Well, they share that side, so I got to set it congruent to itself. So RT is congruent to RT. And that is a reflexive property. So now we got my side, angle, side. I can state my congruent triangles. So triangle, just name the first one wherever you want. I'm going to go with QRT is going to be congruent to triangle. Well, I started with Q, so I got to start with S. Then I went to R, so now I got to go to T, STR. And that's side, angle, side. So I went side, then angle, then the side. And now, since they're congruent, the triangles are congruent, that means all sides and all angles are congruent. So I can state what I'm trying to prove, that angle Q is congruent to angle S. And this is kind of a goofy thing that we say. We say that corresponding parts of congruent triangles are congruent. So we're saying that all the corresponding parts are congruent. So our fancy way to write it is CP, CT, C. So basically, if we ever go from stating triangles congruent and then using either angles or sides being congruent after that, because the triangles are congruent, we're going to use this reasoning, CPCTC. Corresponding parts of congruent triangles are congruent, CPCTC. We're going to use that quite a bit, so get used to it. Well, that's everything. Here's some proofs for you.